Mayong adlaw o mayong adlaw sa tanan. I am Junrie Remollo from the Department of Agronomy and Plant Breeding. And I will be discussing another topic in Agric 44 that would help you understand the entire subject. So allow me to show you my slide. Okay. Our topic would be measures of central tendency. Okay. So to investigate a set of quantitative data, then it is useful for us to define numerical measures that are important, that would describe an important measure or a feature of a data. And one of which is by getting the average. It is getting the average is a method of getting the measure of the center part of a particular set of data. No? Usually those data are arranged in an increasing or decreasing order of magnitude. So measures of central tendency is also known as the measure of central location, and it is any measure indicating the center of a set of data arranged in an increasing or decreasing order of magnitude. And the tendency of typical values to lie centrally within a set of data arranged according to the magnitude, and descriptive measures that are used to indicate where the center, the middle property, or the most typical value of a set of data lies. It's just like, for example, no, when we talk about center or centro, no, centro ng Valencia City, or what we call poblacion. So, as you can see, when we hear the word centro, it is associated or it is coined as the central hub for industry or commerce. And when you go there, then you can avail anything, no, that you want to buy. So that is how important, no, a center is. No? So similar manner goes to our measure of the central tendency, because usually the important features of a particular set of data lie near the center. And that is how important measurement, the central tendency or the central location is. So there are three types of measuring the central tendency. So first, the mean, denoted by the mu for a population and x bar for the sample. The second one is the median, denoted by the mu tilde, the symbol that is like an approximate, and then x tilde for the sample, and then the third one is the mode, denoted by m sub 0 or m sub o. So the mean is the sum of all the given values or items in a distribution divided by the number of values. So as you can see, these are the formula. It's just simply the average. So it is denoted by the summation of xi, where I is equals to n and I is equal to 1. I believe that naiintindihan niyo po kung anong ibig sabihin ng mga symbol na ganyan. Okay? The only difference between a population mean and the sample mean is, of course, as I've mentioned, population mean is denoted by or symbolized by a mu. On the other hand, the sample mean is x bar. And in terms of the n values, the population n value is denoted by a capital N, whereas the sample is a small n. So the characteristics of the mean, it is reliable or a more stable measurement to use, and it is a point that balances all the values on either side, and it is greatly affected by extremes. Of course, we can say that it is reliable or more stable Especially, example, if we want to measure the scholastic capability or record of a particular student, then we can obtain it by getting the general weighted average or the GWA. No? It's actually the mean that we are computing in order to obtain such value. And it is a point that balances all the values because when we get the mean, then we are actually getting the sum of those raw values in the entire set of data. So it is greatly affected by the extremes because one change will automatically pull down the values of the mean, whether if you increase it or decrease it. The uses of the mean, it is to obtain the average value or the series of values. It is an important measure for inferential statistics. Especially, when we talk about inferential statistics, it is concerned with the method of analyzing the subset of a data that would lead you to coming up with predictions or conclusions about the entire set of a data. And then it is also used for interval and ratio measurements. For example, if you want to evaluate the certain value or relative order of a particular item or a particular character. For example, if you want to get kumbaga, the temperature in Celsius, no? It usually appears in a interval type. And then if speaking of ratio measurements, if you want to obtain the standard measurement of the particular unit, no? For example, in getting the value of the yield or the mass or the length, among other things. And then it is used for approximately normal distribution. And the limitations of the mean, it cannot be used if the clustering of the values or items is not so substantial, especially that there is a great dispersal or scattering of one value to another. Say, for example, when you compare 10 and 100, these values are far apart. So we can no longer obtain with a valid data when we get the mean, because each values are very far from the center. And it is easily affected by the extremely large or small values. I mentioned it earlier that one small value can easily pull down the mean. And then it is a poor measure of central tendency if the given values of a distribution do not cluster around the central value. Because we are much more focused of those important set of data which is usually located or which are usually located at the central value or near the central value. And it cannot be used to compare distributions since the means of two or more distributions may be the same, but their characteristics may be entirely different. Say, for example, if we are to evaluate these two set of data or values, the distribution A and distribution B, they have the same mean of 65 but different pattern of variation. Say, for example, if we associate it with or we compare it with the grades of student A and student B, of course they have the same average of 65. If we transmute it to a CMU grading system, then 65 is already belong to a bracket of 2.5 or 2.25 rather. But if we try to look the raw scores or the raw grades, then we could say that distribution or student B is more consistent with his or her grades compared to student A. Okay? So, on the other hand, unbiased and preferred measure of central tendency, but it is greatly affected by extreme values. So for example 1, the number of faculty at 10 different departments of the College of Agriculture are 13, 9, 7, 6, 12, 9, 9, 12, 6, and 5. Treating the data as the population, find the mean number of faculty for the 10 departments. So how can we solve it? So since the data are considered to be finite population as mentioned in the problem, then we just add all the values and divide it by the number of values, which is 10 because there are 10 departments. And it will result to a population mean of 8.8. Another example, a food inspector examined a random sample of 10 cans of a certain brand of tuna to determine the percent of foreign impurities. The following data were recorded: 1.8, 2.1, 1.7, 1.6, 0.9, 2.7, and 1.8. And you compute for the sample mean. So the solution is, being a sample, we have to just add all the values and divide it by the number of values in that set of data. So if we add all the values divided by 7, then it will result to 1.8%. Okay? So that is all about the mean. Then the second one is the median. It is the value of the middle observation in an ordered distribution. So the middle value, or the value that divides the ordered distribution in half. And in distributions with odd number of values, then the median is simply the middle value, yung pinakagitna. Okay, madali lang ma-determine if what is the middle value if the number of values is an odd number. In distributions, on the other hand, in distributions with even number of values, then the median is the midpoint between the two middle values. Of course, when we say it's even, then we cannot pinpoint any single middle value. So we tend to get the midpoint between the two values, which means getting the average of the two values divided by 2. That is all about the median. So whenever you encounter problems that require the value of a median, then you need to arrange all the values in order or in increasing value. Okay? Characteristics of the median: it is easy to understand. Of course, it is understandable. It is easy to compute because you just need to obtain the middle value or the midpoint. And it is not greatly affected by the extremes because we don't care about the extreme values, no, whether you would increase it or decrease it, as long as we could determine the middle value or the midpoint value, then that's fine. We can actually get the value of the median. And the uses of the median: when the average position is desired, it could also be used as an average in getting the general abilities, just like the intelligence test, wherein regardless of what score you obtain, then we could characterize it to what category you belong. And we need the value of the median in obtaining such. And then where there are extreme values or cases, or for ordinal or rank measurements. Because in getting such, then we need to arrange this in order, in an increasing order. Limitations of the median: it cannot be determined if the given values are not arranged according to the magnitude. Especially in a typical problem, then of course one of the competency skills is to to allow you to analyze such problems. And uh, based on what I've said, then if you encounter problems that require the value of the median, then I'm giving you a hint that you arrange it in an increasing order. Then the value of the median is not as accurate as the mean because it is just an ordinal statistic, which means that after you arrange all the set of values, then you could just pinpoint the middle value or the midpoint, and that's it. That's the median. No, and it's not accurate, no? Especially that there are extreme values before and after the midpoint or the middle value. No, whereas in the mean, you are obtaining the value by adding the raw values. And then arranging values according to magnitude is a laborious task in distributions with several values or items, especially if you are dealing with the large set of values. When you pursue plant breeding, then we value diversity, and we could come up with a better result or better data if you evaluate as many data as you can. So that is the sad point or sad part of the median, because it may be tedious or laborious to obtain such value if there is a great value or several value of items. And it is easily affected by the number of items in a distribution. It is easy to compute, but generally, it is not preferred measure of central tendency. Okay? So example, on 5 long exams in Agric 44, a student has made grades of 82, 93, 86, 92, and 79. Find the median for this population of grades. So first, we need to arrange the grades in an increasing order or magnitude. Then we get 79, 82, 86, 92, and 93. Hence, the median is 86. And we use mu tilde since this is a set of population of grades. So since this set of values, the number of the set of value is an odd number because there are 5 values, then we could easily pinpoint the number of or the median. Okay? So example number 4. This is the case wherein there is an even number of values. The shoot length for a random sample of 6 seedlings of adlai exposed under waterlogged condition are found to be 12.3, 13.7, 11.6, 14.9, 13.1, and 16.5 centimeters. Find the median. So of course, we need to arrange first the values of the shoot length in an increasing order of magnitude. Then we get 11.6, 12.3, 13.1, 13.7, 14.9, and 16.5. However, since there is an even number of the set of values, then we need to get the midpoint, which means we need the mean. We need to get the mean of the 2 middle values. So we add 13.1 and 13.7. Therefore, we could come up with a value of 13.4. Okay, see the difference between example 3 and example 4. Okay, and the third one is the mode. It is the item or value in a distribution with the highest frequency or the most number of cases. So the catch is you could just pinpoint the most frequently occurring value. And there are different types of mode. So for example, for set A, so you can see 67, 68, 68, 70, 70, 70, 71, 72, 75, 76, 78. So in this case, the mode goes to the numerous number that are frequently occurring. So since we could identify uh, two numbers, I think that has a frequently occurring value. But however, 70 is greater than 68 because 70 occurred 3 times. So the mode is 70, which is unimodal. And then for set B, as you observe, using, I'm not sure if the same value, I think it's a different value or it's different set of value, then you can observe that there are two numbers that are identified to be the mode, and they have the same number of frequencies. So the 68 and the 79, since they occurred twice. So they are considered the mode being a bimodal, since there are two modes. And then the last one, set C, 65, 68, 66, 68, 69, 70, 72, 73, 75, 76, 78, 80. Since there is no frequently occurring value, then we could consider it as no mode because all have the same frequency. Okay, got it? Easy. So characteristics of the mode, it is easy to determine. It is not affected by the extremes. And it is the simplest but unreliable. Because we could obtain the value by just determining what are those values that are frequently occurring. So it cannot be affected by the extremes. Huh? And then uses of the mode, it is a quick estimate of the average, and it helps to spot a trend, because when we talk about a trend, then it's like a naturally occurring or recurring phenomenon or phenomena of something. Oh, limitations of the mode. It is rarely or seldom used since it does not always exist. And it is very unstable compared to your mean. How much more, or to your median, how much more to your mean. And then it is just a rough estimate of the center of concentration of a distribution. Because when we evaluate a certain population, then I think it is one of the criteria wherein we could describe what is the entire population if there is a frequency of the values that you observe. Huh? However, mode is the poorest measure of central tendency. For example 5, if the donations from the residents of Valencia Estate toward Bukidnon Memorial Medical Center Association are recorded as 500, 600, 100, 500, 500, 300, 400, 200, 600, and 700 pesos, and then 500 pesos, then the value that occurs with the greatest frequency is the mode. So we can identify that the mode is 500. Example 6. The number of movies attended last month by a random sample of 12 agriculture students were recorded as follows: 20312, 425401, and 4. In this case, there are two modes, the 2 and the 4, since both 2 and 4 occur with the highest frequency. So the distribution is said to be bimodal. And example 7, no mode exists in the Agric 44 grades of example 3 since each grade occurs only once. So if we try to go back to the example 3, then as you observe, all of the grades or all of the values are of the same frequency. They only occur once. Okay? So what are the three measures of central tendency? The mean, the median, and the mode. So that is all about this topic, the measures of central tendency. So for your questions and clarifications, first, for my Agric 44 students, then you communicate with your section leaders to relay your concerns or your questions, and they will just be the one to contact me. And for others, for Agric 44 students but are not under me, And of course, for those students who are also taking statistic courses right now, but you are of a different university, then you can reach me up through the contact details are reflected in your screen. You could contact me through email or my Facebook page. Okay, Sir June Updates. So I think that would be all. Thank you for listening, and I hope you've learned a lot from my lecture for this day. Thank you very much, and have a great day.